Modeling of crack propagation in miniaturized and normal SENB specimens based on local failure criterion. Visual abstract. This article introduces the determination of fracture toughness with a new simulation method. The usage of small-scale specimens are becoming widely accepted, therefore the measurements and simulations were carried out on small flat tensile specimens, standard and miniaturized SENB specimens to prove their applicability. For the determination of GTM parameters, flat specimens were generated with 3 different notch radius. After training the artificial neural network, the data from the measurements was used, which resulted in the optimized GTM parameters. To validate the GTM parameters, SENB measurements and simulations were carried out. In this slide, beside the resulting force displacement curves, the fracture surface was also compared, which showed an excellent agreement between the measured and simulated results. Finally, the virtual crack closure technique was modified. The method was originally developed for the simulation of brittle fractures, where the fracture criterion was defined as the limit of the strain energy accumulated at the crack tip. This fracture criterion was modified to the GTM parameters, which allows the determination of the fracture toughness value directly from the simulation. In case of the normal SENB specimens, the measured and simulated fracture toughness results are in good agreement. In case of the miniaturized SENB, the value of fracture toughness is not valid based on the standard, therefore the differences are higher between the normal and the miniaturized SENB results. Conclusions: 2D and 3D nonlinear finite element analyses were performed to study the ductile fracture in the SENB specimens. The parameters of the GTM model were calibrated using uniaxial tensile test data. The good agreement between the simulations and the uniaxial tensile and SENB tests suggests that the GTM model can provide reliable predictions of ductile fracture of structural alloys. The calibrated GTM model was applied to modified VCCT simulations of SENB specimens. For normal SENB specimens, the measured and simulated fracture toughness results show excellent agreement. It was found that the agreement wasn't as good for the miniature SENB specimen, and further investigation is needed to determine the reason for this.